Okay, converting from binary, octal, and hex. Okay, so why does this comes in very handy? You can move between these three bases without going through the decimal. And that makes it very, very exciting, right? So I can ask you to convert from binary to octal, and I don't really have to go through base 10. I can ask you to convert from the hex to binary, and you really don't have to go through base 10. So these three are very unique, and yes, you can get questions on that. So knowing this technique helps a lot. So how do we do that? So let's take a look at binary to octal. Okay, binary to base 8, right? What's the shortcut? The first thing you want to do is to group the binary numbers into groups of 3 bits. This is very important. Okay, starting from the decimal point. So, okay, so if I have a decimal number, yes, put a decimal number here, 1 1 0 1, and then let's put 0.01101, something like that, right? So I have the whole number and I have the fraction. So grouping its group of bits of 3 means that, okay, I start from the radix point. That is the fraction point. Okay, the decimal point. Okay, if we want to call it like that, but it's the radix point. So I start from that, and then to the left, I make groups of 3, right? Make groups. So this one is the first 3, but this one is only left with 1. So what do? I just pad it with 2 more zeros because I need groups of 3. Okay, so that's the whole number side. For the fraction side, we still start from the decimal point or the radix point, and then we move to the right hand side. So this we combine, we get the first 3 bits, right? And then the next one is only 2, right? So what do? We pad it with a 0, because when you pad it with a 0 to the right hand side, you have not changed anything. And then this will be our next group of 3. So this is what we mean by we group it in bits of 3. Okay, so that is step number 1. Okay, that's step number 1. So let's go ahead and erase that. Then step number 2. Okay, so here we are adding the zeros to the left if needed, right? So that's what I just did, right? And then we are going to convert each group of 3 bits to a decimal number individually. So we take each group individually, and then we convert them to a decimal number, right? So for the first one, right? So if you have this as an example, this one doesn't have a fraction, but it's a good example, right? So that's the first 3. The blue one, we have to pad it with a 0, right? Because it was left with just 0 and 1. So we have to pad it for another 0. So we get the 3 bits. So now what do? We take the blue one individually, the 3 bits, we convert it to what? To decimal, right? So 101 is basically 2 in base, is basically 2. So that is our base 8, right? And then we take the other 3 bits, 110, and we also convert it to decimal. So 110 base 2 is going to be what? 6 in base 10, but then that will give us our number in base 8. So now we combine the blue and then the red, which is 2 and 6, and we get our number in base 8, right? So it's basically combine, okay, group all the bits into 3s, and then for each group, find a decimal equivalent, and then just put the solutions together, and you have your answer in base 8. That's it. Okay, so that's simple. That's as simple as it will get, right? That's as simple as it will get. Okay, this will also work for fractions. Okay, this will also work for fraction. Okay, you can also do this because there's no fraction here. You can do this on the calculator. Okay, so all these techniques I'm showing you because when the fractions once come, then you have to know how to do it. But this works with fraction. So when you have fractions, it becomes very, very convenient. And you can just do the fraction part and then the whole number part, do it on the calculator. Okay. So that's binary to octal or octal to binary.